The question we are solving now belongs to test series 11. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a circuit given as shown in the figure. The circuit takes an input of 5 at a phase of 0 degrees volts, and in series with the voltage source there is a 1 ohm resistor, and there is a 3 Henry inductor, or there are two 3 Henry inductors which are magnetically coupled as shown in the figure, and in the circuit there is a 2 farad capacitor as well. The dot convention of the two coils is given as shown, and the mutual inductance between these two coils is 1 Henry. From this data, if the circuit is under resonance, we need to find the angular frequency at which the circuit is under resonance. This angular frequency needs to be found out in radians per second. So for simplifying this circuit, let us assume the mesh currents I1 and I2 as shown. So now upon applying the mesh analysis, we see that mesh analysis is on the basis of KVL. So upon applying the KVL to the first closed path marked, we see that 1 multiplied by phase of I1 plus j omega 3 multiplied by current through the same, that is I1 minus I2, plus the drop across the inductor due to the mutual inductance, which can be written as j omega multiplied by minus I2 is equal to 5 at a phase of 0 degrees. Please note that we have considered the drop across the mutual inductance as drop due to the mutual inductance as minus j omega I2. We know that the drop due to the mutual inductance is j omega I2, and we have introduced the negative sign due to the reason that the current I2 is entering the dotted terminal here, hence it will produce a voltage which is sensed positive at the dotted terminal of the coil marked. Hence, this is a voltage rise due to which there is a negative sign present here. Similarly, upon applying the mesh analysis to the second closed path, we see that we can write the mesh equation as j omega 3 I2 plus, this is a 2 farad capacitor, plus 1 by j omega 2 I2 plus j omega 3 multiplied by I2 minus I1. So these are the drops due to the self-inductance. Now let us consider the drops due to the mutual inductances, which can be written as plus j omega multiplied by I2 minus I1 plus j omega multiplied by I2 is equal to 0. Now let us simplify this equation to get the relation between I2 and I1 as I2 is equal to I1 multiplied by 8 omega square divided by 16 omega square minus 1. This is from the equation 2. From this we can say that the impedance as seen from the source Zs is equal to 5 at a phase of 0 degrees divided by I1, and upon finding this impedance Zs and upon equating the imaginary part of Zs to 0, we see that the omega is equal to root 3 by 4 radians per second. From this we can say that the circuit is under resonance when the angular frequency omega is root 3 by 4 radians per second. Hence the correct option is A.